Hi, Honors Chem students. I'm going to go over this first mass stoic homework problem. If you get stuck, you should watch this video and I'll go over how to do it. And hopefully you can learn how to tackle any mass problem this way. So first of all, we always need a balanced equation. So let's see, we have two O's over here. Looks like I'm going to have to put a 2 here. That gives me 4 silvers. Let me put a 4 here. So this has to be 1. Looks like everything's balanced. Just for practice, this has 1 reactant breaking up into 2 pieces. This is a decomposition reaction. All right. So the question is how many grams? Okay, so immediately we know this must be our X. How many grams of Ag, that's what we're being asked, is produced from 58 grams of Ag2O using the balanced reaction above. So here's, this is the answer that we should get. Okay, so you can always check your answer with the answer provided. If you get that answer, you know you did it correctly. So our first step when we have a problem like this, where in this case, we're starting out with 58 grams, it's always good to label our things, and we need to figure out, okay, here's our question mark here. How much Ag can we produce from our 58 grams? So first step in doing these problems, when there is no limiting reagent involved here, right? We just take this grams and figure out the grams of this. The first step is always going to be to change this grams into moles. Why? Because we need to fill in a BCA table to solve this problem. So the first thing is we got to take this 58 grams of Ag2O and we need to change to moles. To change from grams to moles, we divide by the molar mass, by our grams per mole. Okay, so over here, I'm going to do my work for this. I've got 2 Ags. So my molar mass for Ag, when I look it up on the periodic table, is 107.87. Okay, that's my 2 Ags. Plus, I have 1 oxygen here. Oxygen is 16.00. And so then I can just take my calculator and plug those numbers in and add them up. And I get a total of 231.74 grams per mole. Okay, that's for my Ag2O. Okay, so what do I have to do? I need to divide my 58 grams of Ag2O by my molar mass, 231.74 grams per mole. Okay, so I plug this into my calculator and I get 0.250. Okay, so I'm just going to carry like 3 decimal places here. There are rules about this, but we're not going to learn them. And that's our moles of Ag2O. Always good to label everything. You can see here our grams cancel out. We're left with moles of Ag2O. All right, so what's our next step? We've got our moles now. This is where we need to set up a BCA table. So set up your BCA table with your balanced reaction. So at the top, I'm going to put 2 Ag2O, and that is going to turn into 4 Ag plus 1 O2. So there's my reaction. Okay, so there's that. Let me set up my before, my B, my C, and then finally my A. Try to make some nice straight lines here. Okay, so here's my Ag2O. Where do I put this? Well, I'm going to put it where my Ag2O is. Let me separate my other substances here. Okay, so my 0.250 moles of Ag2O is going to go where my Ag2O is. It's going to go in here. So I have 0.250 moles of Ag2O. We've got 0 of this right before the reaction happens. No products. All right, so now we've got to figure out our change. Well, we're getting rid of all of this, okay, because that's our only reactant. So it has to react away completely. It's like, it basically is the limiting reagent, except in this case, there's only one reactant. So you don't need to worry about, excess reactants or even the limiting reactant. We know that this has to be the limiting reactant. It just has to disappear because we're going to react it all away. So let's get rid of it, okay, and get 0 here. All right, so now it says, how many grams of Ag do I produce? You see how I'm constantly going back to the question to make sure that I'm answering the question that I am supposed to. So that's just a good practice to check yourself. All right, so I'm looking for grams of Ag. So do I care about this oxygen? No. Okay, I don't care about this. I'm just going to cross this part out because we don't care about this part of the BCA table because it's not asking for oxygen. Instead, we'll focus on the silver, which we need to find. We need to find the grams of Ag. Now, remember, BCA tables, always moles. Always moles. Okay, only moles in the BCA table. The BCA table works with moles because we're working with the ratios. These numbers represent the ratios for moles. Okay, so only moles can go in this table. All right, so here's our change. Remember, we base our changes off of the change of the substance that we are limited in. Okay, in this case, we only have one reactant. That's what we're going to base our change off of. So here, remember, our reactants disappear, our products up here. Okay, so, right, we're going to take our change, our 0.250 moles. Oh, let me write that better. 0.250 moles. And that's our Ag2O, okay? I can see I'm going to run out of space here. I'm going to run into this part. Okay, so I've got Ag2O. I need to figure out how much silver, right? So again, I'm going to use my mole ratio. I need to change to silver. Silver has to go on top because we're changing to silver. So 4, let me use a different color here so that you can see it better. So 4 Ag over 2 Ag2O. Okay, there's our ratio between silver and Ag2O. All right, so that's going to be how much we produce. And so if we take 0.25 and then multiply by 4, divide by 2, well, I think you guys can recognize that 4 divided by 2 is just 2. So if we take 2 times 0.25, we get 0.5 moles of Ag, right? We now have Ag because this canceled out here, and we now have Ag moles here, moles of Ag. Okay, so we filled in our BCA table. We figured out the moles of Ag. Are we done? Go back to your question. No, we're not done. There's a step 3. We've got to change these grams. Okay, we got to change 2 grams. That's right. We got to change these moles. 2 grams, right? We've got the moles of Ag now from the BCA table. If the question asked for moles of Ag, we'd be done. But it doesn't. It asks for grams of Ag. So one more step. We've got to change the moles 2 grams. So let's take our 0.5 moles of silver, of Ag. And remember, to change from moles 2 grams, what are we going to do? We're going to multiply by the grams per mole, the molar mass, okay, which we find on the periodic table. So if I look on the periodic table, I can see that Ag has a molar mass of 107.87 grams per mole. Okay, so I just need to take 0.5 times this. Okay, so 0.5 times 107.87. I end up with 53, let's keep three digits here, 53.9 grams of silver. Yay, that's what we were supposed to find, right? Here's our answer. It matches. We were supposed to find grams of Ag. That's what we got. And as a last thing that you should do is you should box your answer, okay, so that it clearly shows that this number you found is the answer to the question that was asked. All right, so I hope that helps you think about mass problems. Let's just summarize the steps, right? First, okay, always good to label, right, your problem. Okay, label your equation with what's given and what you need to find. Okay, just that's just good reading practice for word problems. And then the steps. First step, change your grams into moles by dividing by the molar mass, the grams per mole of that substance. Second step, take what the moles that you got in step 1, put it into your BCA table, and fill out the part of the BCA table that you need to answer the question, right? We didn't need to figure out the O2, so I just crossed that out. We just did the Ag part. Once you find the moles from the BCA table, step 3, change those moles into grams. Okay, then box your answer and indicate that that is the answer to the question. All right, if you have any questions, make sure you ask in class or email me.